All right, so I'm live with AWS again, and I'm going to go through here and share my screen, and I'm going to do this. So I'm going to go, perfect, got this thing going, perfect, got this running. Let's go ahead and get this slideshow going here. Got it. And let's put this into presenter view. Looking good. Okay, so developing solutions with Amazon SQS and Amazon SNS. That's the goal for today to prepare for the certification exam. And let's get into message queue. So one of the things that's pretty cool about message queues on Amazon is that they have essentially infinite scale, and it's typically a producer and a consumer. And in cloud architecture, you want to use decoupling so that you actually can put things inside of a queue that has this huge capacity to scale things. And so it's a temporary repository for messages that are waiting to be processed. And the messages can be small, like a request, or they could even be bigger things like patient records. And then to send a message, a component that's called a producer would go ahead and add that message to the queue. In terms of synchronous processing, a message queue can allow you to both create an asynchronous process and an asynchronous. So first, let's talk about how asynchronous works. If let's say you have a producer and a consumer, the producer would generate a bunch of different messages, and then the consumer would have to wait for the next message, and it's very dependent. So like essentially, this is a tightly coupled system. The problem, though, with a tightly coupled system is that it's not fault tolerant. So if a part of the system fails, then the entire system will fail. And also, if there's a new consumer that's launched to recover from the failure, it must be explicitly that the new producer has to be made aware of the consumer instance. And so in this scenario as well, there's a lot of brittleness available. And so a loosely coupled or asynchronous system is much better because it's a component of an asynchronous process. And in an asynchronous system, the producer would generate a message, put it in a queue. The producer then generates another message, puts it in the queue, et cetera, et cetera. And then when the consumer reads a message off of the queue and processes it, the producer isn't impacted if this consumer fails because the message has not been deleted yet from the queue. So it's a very elegant way to approach scale. And that's why I personally like using SQS. So an asynchronous solution is a lot more scalable because you can add or remove capacity on either end, right? So you can have producers creating more messages, you can have the consumers consuming more, and you don't have to actually worry about blowing things up. So let's talk about how this works with Amazon SQS. So SQS is a fully managed queuing service, and it allows you to decouple and scale microservices, distributed systems, serverless applications. You can use it to send, store, receive messages. Some of the things that are really important about SQS include that it's fully managed. And so this means that you can use all of the ongoing operations and underlying infrastructure at the same time. And with Amazon SQS, there's also no upfront cost. So there's no need to acquire, install, configure messaging software. Also, the messages are reliably delivered. So you can use SQS to transmit any volume of data at any level of throughput without losing messages or requiring other services to be available. Also, Amazon SQS would enable you to decouple application components so that they run and fail independently. And this causes overall fault tolerance to the system. The system could elastically scale in a cost-effective way. That's another great advantage of SQS. And in just in terms of cost, the costs are based on usage. And this also allows you to benefit from using SQS. And then the sensitive data. So Amazon SQS supports server-side encryption, which means that you don't have to worry about data being intercepted in transit. So you can integrate SQS with a lot of other services. And this is another huge component of why SQS is so amazing, is that you have a Lambda function. You could set it up to trigger and get called every time a new event is actually put into SQS. And then in that particular scenario, you could do some kind of image processing application. So that's really an event-driven architecture, and one of the reasons why people like using SQS. There's a couple different kinds of queues with SQS. The first one is the SQS queue type. There's standard queue, and this one would be the ordering is not guaranteed. There could be duplicate messages, but the benefit is that you get essentially unlimited, ability to consume or send messages. There's no bottleneck at all. Like, you can't actually go faster than it can handle things. In a FIFO queue, or first in, first out, the queues are designed to enhance messages between applications. And so these support up to 300 messages per second if you're not batching. But if you batch, you can actually support up to 3,000 messages per second. So with a standard queue, a lot of scenarios that you can think of would be, decoupling the live request from background work, allocating tasks to worker nodes, like let's say credit card transaction validation requests, batch messages for future processing. Now, in the case of FIFO queues, it would be things like bank transactions, right, where the order is important, or credit card transactions. Make sure you're not processing more than one transaction at a time. Course enrollment, preventing a student from enrolling in a course before they register for an account. These would all be good examples of FIFO. So let's talk about some of the developer concepts of SQS. And in particular, one of the things to consider is a producer component sends a message to the SQS queue, and a consumer component retrieves the messages from the queue, and the visibility timeout period starts, and then a consumer component will process the message and delete it from the queue during the visibility timeout period. And so you can perform these actions with send message, receive message, delete message. These are all ways that you would actually go through and process the SQS messages. Another thing to be aware of is that with SQS, you can send the message individually, or you can batch send up to 10 messages at a time. And then the producer would send a message to the queue, and then the queue would redundantly store the message across multiple SQS servers. The send message operation will deliver a message to a specific queue, and this one would take a message body, a message attribute, a queue URL, and a delay second. So a delay second is the length of time in seconds to delay a specific message. And then after you send a message, the SQS return would have the message ID. And you can retrieve more than one message. You can retrieve up to 10 from the queue by receiving messages with the receive message operation. And each time you receive a message from a queue, you'll receive a receipt handle. And then to delete the message or change it versus visibility, you would actually provide the receipt handle, not the message ID. So when a consumer receives or processes a message from the queue, the message remains in the queue, and Amazon won't delete it automatically. The reason for this is in a distributed system, you don't have a guarantee that the consumer actually got it. And so it's up to you as the developer to actually delete that queue. And that's where the receipt handle comes into play. And so another one to consider is with a FIFO queue, the producer or consumer can do multiple retries as well. So Amazon SQS will use a polling model to receive messages from a queue. And by default, you can receive a message API call. And this is called short polling, where it samples a subset of the servers. But if the messages in the queue is small, let's say fewer than 1,000, you'll likely get fewer messages than you requested by just doing a receive message call. If the number of messages in the queue is really small, you may not receive any messages from a particular receive message. If you keep requesting the receive message, Amazon will sample all the servers until eventually you receive all your messages. With a long poll, Amazon is a little different in that it will query every single server and wait until a message is available until the queue sends a response. And the reason why you'd want to use long polling is it helps reduce the cost because you don't have to make a bunch of requests constantly for it. Now, an example of a query to receive messages from a queue named a test queue, you would maybe have to put in the max number of messages, the wait time for a second, and also the visibility timeout when you're making a request. To prevent a message from being received and processed again when the visibility timeout expires, what your job is as a developer, you have to delete the message. So this is a little bit not intuitive for people that are using SQS, is that you do have to delete the message after you've successfully processed it. And another thing to be aware of is that a query request that deletes a message from a queue, the parameter receipt handle is the receipt handle that's associated with the message that's deleted. For a message that you cannot process for some reason, there's something called a dead letter queue in Amazon SQS. And after a maximum number of processing attempts, then it will go into that dead letter queue. Now, the advantages of this is that it can actually be something you take a look at later and figure out what's going on. And so mostly the things that we've talked about so far have been send, receive, delete message API, but there's also a create queue API that you can do the same thing. And you can set up other things like set queue attributes, list queues, etc. There are 3 ways to secure SQS. One of them is IAM, another one is encryption, and a third is VPC. Now, these are all things you'd use in many scenarios with AWS. Now, SNS is similar to SQS, but a much more lightweight version. And the main reason people use SNS is it's a pub sub where you fire and forget. So basically, in this scenario, you could potentially send text messages or send notifications to a mobile phone, and you could do them in parallel. One of the little tricks about SNS is if you wanted to write massively parallel code in Python, one of the things you could do is just write messages to SNS and have lambdas on the other side. Amazon SNS is a highly available, durable, pub sub system, and it decouples the microservices and the distributed systems and serverless applications. And also Amazon SNS manages the delivery or sending of messages to endpoints or clients. And so a good example would be, again, you could put it into SNS once as a topic, and then you could send it to Lambda, SQS, HTTP, email, mobile notification. So you push once, send many, and you don't even care if they receive it. But it is a great way to do distributed computing. Also, a message has to be processed by more than one consumer. You can actually combine it with a fan out design pattern, which is pretty common. So fan out is when the SNS is sent to a topic and then replicated to multiple SQS queues, for example. It would be a good example of a fan out. You also can do a fan out for image processing. So you can have a topic that send a message when a user uploads an image, and then each one of those images as they're getting processed could invoke a Lambda function that would separately do some kind of transformation to the image. That would be a good example, like a thumbnail, an image for mobile, and then an image for web, right? And so each of those 3 Lambdas is subscribed to the topic and then puts it into the S3 bucket where the resizing occurs. So let's talk about some of the developer concepts. The few common API calls would be create topic. This would be creating a topic where notifications can be published. A user can have up to 3,000 topics. Subscribe. This is when an endpoint is being subscribed to. Confirm subscription. This verifies an endpoint owner's intent to receive messages. Delete a topic would delete a topic and all the subscriptions. And then publish would send a message to all of the topics subscribed endpoints. Except for SMS, Amazon SNS messages can contain up to 256 kilobytes of text data, and you could put that in XML, you could do it in JSON, you could do it in unformatted text. And when Amazon SNS sends a message to SQS queue, it will encode the message as a JSON document that contains the metadata about the message. And this allows you to have a message delivery that reduces the need for endpoints that process JSON formatting, which is a nice feature to have. And also, SNS topic subscribers receive every message that's published to a topic, and you can receive a subset of the messages by doing a filter policy. And a filter policy is a great way to actually, do some kind of filtering event so that you don't necessarily have to respond to every message. So if you publish a message to a topic, Amazon SNS would then compare the message attributes to the attributes in the filter policy. And if any of the attributes match, Amazon SNS will then send the message to the subscriber. So it could be like, in an attribute type, event type, and where the value is product page visited, then that goes into, let's say, the search engine subscription versus other things would go to the Lambda subscription. So it's a great way to actually make routes. So there's 3 ways, again, to secure SNS. Similar, there's IAM, there's the server-side encryption and key management service, and there's also VPC. Now, there also is something called Amazon MQ or message queue, and this is a managed message broker. And so a managed message broker for Apache ActiveMQ is one of the services that you can use on Amazon, and allows you to set up and operate message brokers in the cloud. And the message brokers allow for different software systems, and it allows you to make an easy migration to the cloud while preserving connections. It also supports open standards like Java, .NET, AMQP, Stomp, MQTT, WebSocket. So really, it's a more of like a plug and play system that works with a lot of existing standards that have been out for a long time. So what's the big difference between, let's say, SQS, SNS, and MQ? So for MQ, it's really for application migration. So it's really backwards compatibility. So if you have existing, let's say, RabbitMQ servers or something like that, you would want to use the AMQP protocol. And so you can actually kind of backport things. And also it's feature rich, and you pay by the hour. But SQS and SNS, the big difference is they're like cloud native. So they're born in the cloud. They use web protocol, unlimited throughput, and you pay for a request. And you cannot do PubSub with SQS, but you can do it with SNS. And so what are some of the use cases? I think really the strongest use case would be a hybrid cloud for Amazon MQ. So you'll have an existing message broker, you put one in AWS, and then you essentially can sync those two things and then migrate whatever you're doing into the cloud-based environments. So in a nutshell, all of these queue-based services on Amazon are quite powerful. And they're definitely something that I would recommend playing around with. And they're, I would say, one of the best features of the whole platform actually is SQS and SNS. All right, next week I'm going to cover Lambda, and then after that API Gateway. All right, so see you again soon.